Hello students, today we are going to learn complete the reactions from haloalkanes and haloarenes. So there is a type in organic chemistry where they will give reactant side, product side will be empty. So we have to fill the products. So the first question asks, so here it can be general reaction or specific example too. The first reaction it is with PCl3 or px3. So whenever we take this, we will be getting alkyl halide with He3PO, He3PO3. This will be the product. Then with this, we will be getting RCl. If you take bromine or iodine, you will be getting bromine or iodine. Br or Ri. There are two products formed. So in third reaction, the sulfuric acid. So this NaHSO4 will be formed. So you'll be getting two things, NaHSO4 and HBr. See, we have one more H here. So HBr will be formed. So this HBr can be written like this. So RBr plus water will be formed. Coming to the fourth reaction, this is SOCl2, which is a chlorinating agent. So SOCl2, whenever I see SOCl2, what should I do? Split into Cl, SOCl, SOCl2, split like this and write the product. RCl, SO2 plus HCl. Then ZnCl2 plus HX. This is Lucas reagent. So whenever I take Lucas reagent, so RCl will be formed. Tertiary is more reactive than secondary than primary. And water also will be formed. So PCl5, this is also a chlorinating agent. So what should I do? Split into Cl, PCl3, Cl. So what will I get? RCl, POCl3 plus HCl. Then this is chlorine UV light, meaning free radical reaction. Correct. So this is CH3, CH2, CH2, CH2Cl, one product. We have to check the possibilities. So here there are two possibilities. This is one, this is two. Again, if I come from this side, this is one and two. So two products I will get. So 4 carbon with second position la chlorine. So this will be the product. This will be the product. Next reaction with Hi and alkene. Hi and alkene. So this is Markovnikov of addition. So the negative part H plus and I minus. So the negative part will go to carbon having less hydrogen. So CH3, CHI, CH3. This product will be formed. Coming to question number 9. Question number 9, bromine and CCl4 will form vicinal dihalides. So Br, CH2, CH2. Question number 9, bromine and carbon tetrachloride will form vicinal dibromides. So we have to write this product. Then RX and NaI, acetone கொடுத்தாலும் கொடுக்கலனாலும் it is Wilkinson reaction only. So this I will go here and this will form. So 10th reaction is Ri plus NaX. Next, silver fluorides. So it's Schwarz reaction. So Schwarz reaction, what will be the product? Fluorides and AgBr. Next reaction, toluene plus X2 Fe dark. If Fe is given with light, it will form side chain chlorination, but it is given as dark, so it will undergo electrophilic substitution. So since CH3 is given in this place, I also write here, and this Cl or Br, it is ortho para directing. So 1 I take X, so X ortho position like X, and the next product will be, this is ortho, this is meta, this is only para. So according to this, I should write like this. Question number 14. Aniline with NaNO2HX. So diazonium formation. It will form diazonium chloride. And when this diazonium chloride reacts with Cu2X2, it will form X. It can be chlorine or bromine. And Ki warm. So it will form iodobenzene. So these are the important reactions of diazonium. And then when coming to next reaction, which is 16th question, alkyl halide plus Mg. So it is Grignard's reagent. So what will I do? What should I do? This Mg will go in between carbon and bromine. So CH3, CH2, MgBr will be formed. And then on hydrolysis water. So split this into H plus and OH minus, and split into magnesium is a metal, so it will get positive, so R will be negative. So this H will go here and this OH minus ions will come here. So RH plus Mg, OH and X will be the product. And then 18th question, Rx plus sodium dry ether. Sometimes it will give, they will give, otherwise if they don't give also, it is Wood's reaction only, sorry. So this is R. If you take R group here, you will get RR and NaX will be formed. Okay, in this 19th, 20 and 21, 22 question, both reactant and product are given, but the question mark here is the reagent. So this is chlorine is converted into OH. So what is this reaction? This is Dow's process. Dow's process. So during Dow's process, this is actually nucleophilic substitution. Nucleophilic substitution in aryl benzene or aryl halides is not possible. So at normal room temperature and pressure, it won't happen. So we have to give high temperature and pressure, which is 623 Kelvin and 300 atm. If I introduce nitro group is electron withdrawing group, it increases speed. So the temperature will reduce to 443 Kelvin. NaOH should be used. NaOH should be used in all the reaction, almost in all the reaction. The temperature is 443 Kelvin here. And if I introduce 2 nitro group, which is 2 electron withdrawing group, so the speed will even more increase. So now the temperature will even come down to 368 Kelvin. Okay, when 3 nitro group introduced, only warm is more than enough to get the product. Okay, question number 23. See, this is electrophilic substitution. Electrophilic substitution reaction. So in electrophilic substitution, you have to check two things. First, this chlorine order nature. So this is chlorine, it is connected with single bond. So this is ortho-para director. And then what is the electrophile formed? So during chlorination, Cl plus will be formed. So you have to write the same reactant without any change, and this chlorine will go to ortho and para. Ortho and para position, since this chlorine is ortho-para director. And then this chlorine with nitrating mixture. So during nitration, this electrophile will be formed. So what should I do? I should write chlorobenzene as such, and nitro group in the ortho position and nitro group in the para position, since it is nitration. Next reaction, sulfonation. So sulfonation, again, this will be chlorobenzene with SO3H in ortho and in para. Again, this is Friedel-Crafts acylation. Friedel-Crafts acylation. So what is the electrophile form? CH3CO plus. So what we have to write is COCH3. Usually, we will make mistake here. We usually write CH3CO. The CO can't exist at the end, so you have to write COCH3 only. This is one common mistake students will make. Please avoid this. Next, it is chloro COCH3. Next, this is Friedel-Crafts alkylation. This is Friedel-Crafts alkylation. So what should I do? CH3 plus will be formed. So write Cl and CH3 on ortho and CH3 on para. Ortho and para products will be formed. Next, ether sodium 2 alkyl halides. So this is Wurtzwittig reaction. So we will be getting benzene ring. This NaX will go as NaX. So this R group X. So this R group will come and attack here. So you will get this product. And here it is 2 aryl halides with sodium dry ether. So here you will be getting diphenyl. This is also Wurtzwittig reaction. Fittig reaction, sorry. Okay, the next reaction, alkene is there and HBr. So HBr, Markovnik of addition, Markovnik of reaction or Markovnik of addition. So during this, the negative part, so this is H plus and this is Br minus, the negative part will go to carbon having less hydrogen. So you have to write this, then double bond, H, H and Br. Because this bromine will go to carbon having less hydrogen. Then this is HBr peroxide. Our only focus should be with this part. This is inactive. We are not going to bother about that, which doesn't mean we will not write it on the product side. We will write, but there won't be any change in that structure. So this is HBr peroxide. So CH2Br will be coming. CH2Br. Then this is also alkene with HCl. So this is a positive and this is negative. The negative part will go to carbon having less hydrogen. So CH3, CH2, CHCl, CH3. Since it is Markovnik of addition. Markovnik of addition. Again NaI acetone. So initially it was general reaction. Now they have given specific example. So what should I do? Sorry. What should I do? I should write iodine here because this is NaI. So iodine will come and Na and Br will go as NaBr. And then when coming to this reaction, this is also given in NCERT book. So we are going to add HCl to this reactant. So now there are two possibilities. Either this water can be removed and this chlorine will add here, or this water can also be removed. There are two possibilities, removal of water. But this reaction, so the reaction which I wrote here, is not possible. This is not possible because here we have partial double bond character. This chlorine oxygen which is placed will have partial double bond character. So bond breaking this bond is not possible. So we have to write the whole reaction with OH and CH2Cl. So because of partial double bond character, this bond cannot be broken. So you'll be getting this structure. Then again HI and alkene. So you'll be getting the negative part will go to carbon having less hydrogen. So high will be the product. Direct NCERT reactions only. And then here they have given one big structure and bromine UV light. So this is free radical. So free radical bromine nitro group, there won't be any change here. So this Br will go to secondary carbon. There are two possibilities possible. This Br will go to this CH3 and it will form. So this product is also formed, but in minor quantity. CH2, CH2Br. The Br you should write it at the last. So this also will be formed, but this is minor. So the secondary, the bromine which is connected with the secondary is major product. So you have to write this product. Again, SOCl2. SOCl2 is a chlorinating agent. So whenever you see SOCl2, split the bond into Cl, SOCl. So what will I get? I will get chlorine, SO2 plus HCl. Now heat and UV light. Again, this is bromine, so free radical. So now I should write benzene ring, not cyclohexene ring. Now this Br will go to this carbon because the bromine will go to free radical alkylation only. But this is alkene. So either this bromine will go to this carbon or this carbon. So you can write any one product. So the double bond will not be affected. Next, chloroform with O2, light is given. So this will form COCl2 plus HCl. This is highly poisonous gas known as phosgene. Carbonyl chloride or phosgene. So this is also 2. This is also 2 since they have given 2 on the reactant side. So we should write the complete balanced chemical equation. Next, question number 40. KCN and ethanol. So this K and Br will go as KBr and you will be getting cyanides. And then again SOCl2 chlorination Cl SOCl. So you should write CH3 CH2 CH2 Cl SO2 plus HCl. Again here they have given KOH ethanol. So ethanolic KOH. So elimination favors. So ethanol KOH elimination. So elimination. So we will be getting this product. HBr, dehydrohalogenation or elimination favors. Again this is HBr and alkene. So the negative part will go to carbon having less hydrogen. So CH3, CH2, C. There are 2 CH3 already given there and we have to write bromine. So this product will be formed for 43. Next 44 reaction is nothing but Williamson ether synthesis. So here this Na and Cl will go as NaCl and you will be getting C6H5O C2H5 ether, which is nothing but Williamson synthesis. Because one is sodium alkoxide and one is alkyl halide. Again NaAcetone, so it is Filkinston. So you will be getting iodine product. And then we have water and aqueous. Aqueous NaOH is given. So whenever aqueous NaOH is given, substitution reaction takes place. Substitution. So what will be the product? So wherever Br, so you have to replace with OH. So just to replace with OH, the other carbon you should write as such. Aqueous KOH substitution, alcoholic KOH, ethanol and KOH elimination. Most important point. And then again HBr peroxide. So again this is anti-Markovnikov. The negative part will go to carbon having this square. So CH2 Br. Okay, so I'll be sending you this PDF. So take 1 or 2 copies print out and write the reaction again and again to get the clarity. Thank you.